Topic 6 has one objective. We're going to model polynomial functions in real-world situations. So in this video, we're going to look through three different types of regression equations, polynomial regression equations: quadratic, cubic, and quartic. And we're going to pick which one is the best line of fit based off of the r squared value, which is the correlation coefficient. All right, so just preferencing that. So in this video, we're going to be looking at sets of different data and trying to find how to describe that data and put that data in a scatter plot and create a line of best fit within that data to make predictions that will happen in the future or find the maximum or minimum of this certain type of data. This is all done on a calculator, and you've done this before in Module 2, just working with quadratic regressions, and now we're going to introduce cubic and quartic as well, because those will come into play and they'll become a better line of fit depending on the data set itself. If you notice here, there are three pictures given to you, 1, 2, and 3. The first one is linear. If you notice that linear line, it goes in between all these dots, and it's really close to this dot. And as far as line of best fit, that might be the best one, but if you notice, because of the distance away from the line from each of the dots, I would say that the correlation coefficient, or how accurate this model isn't very accurate because of how far away the dots are from it. This one, number 2, is a little bit better. Some of the dots lie exactly on it or really close. But then finally, if you notice in graph 3 over here, all the dots rest on that line. So this is a quartic regression, a polynomial or quartic polynomial regression. And this correlation coefficient, the r squared, would be very close or exactly 1 because all those dots hit on that line. All right. So before I show you how to do this on your calculator, we just have to fill in some of these blanks for the notes. If you note, like quadratic is the power of 2. I'll just put x squared. All right. So for types of polynomial regression equations, that should be familiar to you. Cubic is x cubed, and then quartic is x to the 4th. That's all that means. That's what that's referencing. And then r squared is going to come into play a lot in this process, because r squared is going to be the way you choose which one of these three regression models to use. All right, so r squared is called the correlation coefficient. And then the closer it gets to 1, the stronger the correlation, all right? So I'm going to put, if r squared equals 1, that means strong. If r squared equals 0, or anything close to 0, that means weak. So, for example, 0.9996, that would be a strong correlation coefficient because that's very close to 1. And then over here, 0.0024, that would be a very weak correlation coefficient because it's closer to 0. All right, so just keep that in mind as you're working through your calculator and you're checking your r squared values, your correlation coefficient. Closer to 1 is what we're looking for. All right, and that's going to determine which one of these three quadratic, cubic, or quartic regression equations to use for the given data that you're working with. All right, so now to the calculator stuff. The I do example problem I'm going to run. The following data represents a hypothetical number of albums Mr. Nelson will sell over the course of his lifetime. At one point in my life, I did want to play music and live at the beach and sell records, and it didn't happen, turns out. But if this were the case, let x represent how many years from present day it is. So if x is 0, then it is present day. If x is 5, then it's 5 years from now, 10 years from now, 15 years from now, and 20 years from now. And part A is what I'm going to show you in the calculator. All right? It says determine the polynomial model that seems most appropriate. That's the new learning in this process. Okay. So previous learning, let me bring up this calculator. Previous learning we've worked with this calculator before. All right, so I put the steps in red. You're going to hit Stat, Edit, and then Enter into L1 and L2. So I will go back to my home screen, and you hit Stat, Edit, so enter on Edit, and then I've already entered them in because it takes a little bit of time, so please take a moment on your calculator and get your calculator to look like mine. I've just entered in these X values and these Y values. Remember, X values go into L1, Y values go into L2. Alright, then the next step, step 2, says stat calc, and then I'm going to run the three different correlation coefficients, or three different quadratic models. Polynomial models, sorry. So it's quadratic, cubic, and quartic is what I'm looking at. So then I hit stat, go over to calc. I'm going to try the quadratic regression first. Alright, I hit enter, and then I hit enter one more time. Now on this calculator, it doesn't show you the R squared value, but on your calculator it'll be able to, as long as you have the stat diagnostics on. And if your calculator isn't showing this at this point, if you don't have an R squared value, please raise your hand and I'll come help you turn the stat diagnostics on onto your calculator. But this R squared value, or correlation coefficient, for the quadratic regression, I did it on a different calculator, is 0.763. So I'm going to label that up here. R, that's an F, R squared equals 0.763. So if you notice, that's closer to 1 than other numbers could be, but it's not as close as I'd probably want it to be. Alright, so that's the quadratic. Now the cubic we're going to label as well. So please write these down as we're going. If I run the cubic now, I hit stat, go over to calc, and down to the cubic option and hit enter. I'm just showing you what I would do on a calculator if I was doing this problem myself, and I hit enter. These are the values for the cubic. Again, that's the A, B, C, and then the D term. So that would be the cubic term is the A, B is the quadratic, C is the linear, D is the constant. But again, it doesn't show the R value. So as you're practicing this, if you ran the cubic on your calculator and you hit calculate, your R squared value should be 0.9998. Alright, that's what you should get here. I'm going to put 0.9998. Alright, so that's looking pretty promising. That's closer to 1 than 0.763. But we have to try one more. We're going to try the quartic now. Quartic. I say that weird. R squared equals. So, in order to try the quartic, I go back to my calculator. I'd hit stat. I'd go over to calc. You late. Then go down to the 7th option. Hit enter. And now if you notice, it gives me 5 values, A, B, C, D, and E, because it's a 4th power, then the 3rd, then the 2nd, then the 1st, then the constant of E. But again, no R squared value. This calculator doesn't do that. So if I would do that on a regular calculator, the R squared value should get, you might have to scroll down one. It has an arrow on the screen after the E. To scroll down, you press the down button. And R squared equals 1 in this case. I have an R squared value equal to 1 for the quartic regression. So that means then that our correlation coefficient, if it equals 1, is the strongest it can be. And in this case it is. So we're going to use this equation, alright? 8.666667 times 10 to the negative 5th. I'll tell you how to write that in just a second. And then minus 0.015933333. All of these, it's going to become our y equals equation. So this is going to be a little bit of a tedious process, but this is what we're going to put into our y equals in our calculator and also listed on our paper here to show what model we are going to use to model this data the best we can. Alright, because eventually we want a graph that looks something like this on the top right here, the 3rd one here. Alright, so I'm going to put that into my y equals and also write it down right here as well. Alright, I have wrote my equation in blue here. Y equals 8.666667 e to the negative 5th. That e to the negative 5th just means times 10 to the negative 5th, meaning that that decimal will move 5 times to the left if we want to write it in standard form. That's technically in scientific notation form. So in your calculator you can actually just put times 10 to the negative 5th if you want to make a note of that. And then remember, you have to include x to the 4th. This is the quartic term, then the cubic term, and you have to include x cubed, then the quadratic term, x squared, then the linear term, x, and then the constant coefficient. All right? Now, please write that down, and now the important part is to actually enter this into y equals. I've already done this, so please pause the video at this time to get your calculator to look exactly like mine. You might look a little different as far as how it's presented into y equals. I think it extends more, but if you notice, I put 8.6666667 times 10 raised to the power of negative 5. That's what that looks like. And then I put x to the power of 4. That's how I would enter that into the calculator. And I put minus the cubic term, all of the decimal points. We have to be very specific on this so we can get it as exact as possible. So please pause your calculator and put this y equals equation into your own calculator. Pause the video, not the calculator. Alright, you should have your equation entered into your calculator just like mine. And then if you didn't make any mistakes, now mistakes would be instead of a minus sign, you use the negative sign. That happens a lot. Or you forgot an x, or you didn't raise it to the power it needs to be raised to. So check those things if your graph doesn't look like mine, alright, before you start to ask questions. But if you're still not getting it, then please raise your hand because this is important to get. Now, you have to go up and turn the plot on, remember, because we're running a stat plot. Then if that's, I scrolled up and hit enter, now it is highlighted, okay? Then I hit graph. Your screen should look something like this. And mine takes a little bit longer to load. And if you remember to look at a picture of statistics, we're going to hit zoom and then go down to number 9, zoom stat. That'll give us a better picture of what this function, there's the bell, what this function is actually doing. And if you notice, this is a very good model, and it is a very good model because the line of best fit, the quartic regression equation, the y equals we just discovered, hits every one of those dots. Alright? So once we get this, now we can start answering questions about the actual data itself. And so in this video, I'm just going to show you how to find a specific x value in the future based on this model, how much it would estimate I would have in that time. Alright? So this is the next part of this video. This is part B. So part B says, how many albums will I sell 27 years from now? And then do you have much confidence in this prediction? And we're going to explain that, alright? So there's two ways to do it. 27 is an x value, right? It's a year. I can input 27 in for my x's into this equation, and it will spit out an output of a y value. That would be a good estimate. But instead of doing that, I want to use my calculator since I just did all that work to set it up correctly. So if you remember, all the magic happens of trying to figure things out with the calculator in second trace. That gets me to the calculate screen up here. Now, a bunch of options come up. We're looking for a specific x value. Remember, sometimes you'll do minimums, maximums, where they intersect, or if an x-axis is 0, but in this case we want an x value. I'm going to hit enter on 1. Then I'm going to hit enter, or I'm going to push in, plug in 27 for my x value that I want. I want to know 27 years from now, how many records will I sell based on this model? And it says error invalid. If you ever get that screen, I'll hit second mode to quit again, then hit graph. That just means the window isn't big enough. Alright? So I'm going to hit zoom out and hit enter, enter. That should give me a big enough window. Because we needed to have 27 available on this x-axis, and before it wasn't. So now I'm going to repeat the same thing, second trace value, and x equals 27. And hit enter. Now it gives me an estimate of it. It says that my career is going to tank, and because it's going to tank, I'm actually going to lose albums or lose money. That's actually probably pretty true. That's probably why it didn't happen to begin with. But the estimate itself states that from 27 years from now, I'm going to owe 3.77 million records to the public, I guess. And that would be my answer for part B. So let me punch that in quick. I'm going to pause that and type that. At the X value of 27 years from now, I sold negative 3.77 million albums. So technically I had to give them back. Something happened. Now, this is very accurate because of the correlation coefficient. That's how I would answer this. And that would always answer that based on the correlation coefficient. How confident is this prediction? It's very